one thing that we wanted to make available on the platform is continuity potentially to other methods that people are using in the lab or other courses that you're taking, coding and visualization. What we did, and you can see in this little video, is after you complete a pipeline, you probably notice that there's a zip file called rpack. So for example, PCA will have a whole zip file called PCA rpack. Now we're going to take some of these R files and show you how to modify them. Where everything is a little bit more clear, you can generate those yourself.
Okay, now let's go to the folder called 5 platform R scripts. Here we prepared 4 scripts for dealing with PCA, H clustering, or SVM, and stepwise LDA. Today, let us consider PCA. And here we have PCA.R file. Do you have an RStudio? Yeah, great. We can open it with it. Yeah. Okay, and here we see the code. Each file starts with needed libraries, so you can install them in order to run this. Do you know how to install libraries in R? Just install packages. I think you have ggplot too if you have RStudio, and we can just simply run it. And that's all. We have PCA plot.pdf, and it already, yeah, and we see it at just one click, and script works. Okay, let's go through it. We see options from the platform. Remember, we were selecting something like transpose, center, scale, how many principal components to draw in the web interface. And here we have all these options in the code. So you just can modify input file, you can transpose the data or not, center the data, scale, and so on. So this is just simple script. Not so simple as if you write it by your own hands, but okay, so let's start. Just look by code chunks. First, we read the data. So it has a header. We have row names in the first column. Yeah, and that's all. Then it's option to transpose the data. So we have done it. We have already done it for you. So you know, transposing the data in R sometimes is not so simple because we have some text columns, text rows, and these all are already handled. Yeah. Then we assign some group names, and here's a main line calling PCA, just PRC function. It's from stats package already installed in the R built-in package. And then about drawing, you will see PDF, and if you are writing a manuscript or something else, perhaps you want a more beautiful plot than this is. Yeah. So you can modify this string, and we have already improved script in R code directory. Here we have PCA folder 2. It is a file for generating such pictures. So you see that we have percents of variation explained by the principal components. Here we see some group labels, and we have sample names instead of points. And let's see how we can modify our script to draw beautiful pictures. So you see that first rows are probably the same. We just load the data, just read the tables, transpose it. Here we transpose, assign numeric class to all expressions. Okay, let's see how we can visualize. In platform code, we use ggplot2 library, and here we use ggfortify library. It's just a package aimed to PCA plots, and here we see how it works. The function is called autoplot. Here we pass result of PCA. So here I applied PCA, and I pass this object to the just as argument. Then I say from which column to take colors to our groups. Here I have some data frame called groups with column with group names, and I say that please take the colors from that data frame. Then I have option label is true, which just draws label names on this plot. And yeah, I can set label size, shape equal false. Let me set it to true and see what happens. And now I removed shape equal false, and I see points here. So shape it's just an argument for drawing points. I think that they're not needed now. It's more beautiful without them. So we can. Okay, and then frame is just for drawing these ellipses here. And here we have option frame type. And just for practice, please remove it and look what happens. Just run this code by yourself. Remove it. And you see that we have polygons instead of ellipses. Okay, so and I have commented there are some other options which are perhaps hard to understand because there are some have mathematical meaning, but let us uncomment these strings and see what will happen. Okay, so these arrows are called loadings, and what does it mean? Let us imagine, for example, three-dimensional space and three axes. You know they are orthogonal to each other, and what actually PCA do? It selects one more set of axes, for example, just like this, and then make a projection to two of them, and then we can project initial axes too. So these axes are projections of initial axes, and our initial axis was gene names. Yep. So for each arrow we have gene name, and how to interpret this picture. For example, let's take this gene. We can see if we go by direction of this arrow, then expression of these genes is growing. So, and we see that these two groups are located, these two groups and this group are located just on the line of this arrow. So it follows then big values of this gene expression are associated with these two groups, and small values with this group. So we can just go by these arrows and see how the gene expression affects to the separation of the groups. So it is really important. And we see that some genes are not important, just short arrows.
So is that clear?
Yeah.
It wasn't very clear to me. So if I look at this picture and I see N is G, 65618.
Yeah.
As opposed to N is G, yeah, that one. So what can I know about these two genes?
You can know that big expression values of these genes mainly correspond to this group because arrow goes here, and small values correspond to these two groups. So it's yeah. So that's a projection of initial axis. So it's really makes sense to use. Yeah, and most long arrow is the most informative gene in our case. Okay. Yeah.
Why there's nothing associated with the protein?
Okay, and that's about PCA. Remember, we created a heat map, and we've seen that to obtain much information, we need to replace columns just by colors, and this is really difficult to do manually. And we can use heat map in R, and it automatically does this column replacement, and we will see a really beautiful heat map, which indicates that this is the first group. Second, we have a code for it in R code direction. Here's a heat map folder, and we can open it. Studio. Okay, the start is just pretty same that in PCA. We just load the data and transpose, because all machine learning methods actually wants to sample be row names, not column names. But for biology, it's more convenient to use it by column, so we need to transpose them each time. Here I have a huge heat map call, and let's reduce it and step by step append some options and see what they actually mean. And now that is, you see power of R, just comparing with Excel plot. Here we have some hierarchical clustering, which orders these rows. And here we see just some groups that they are all red. Here we see green, and just they are all sorted in proper way. So let us see how it works and which options do we have. Okay. Let's copy it, paste here, and command this one, and remove all options from here. So calling heat map from scratch in R. Okay, and that's how it looks. You can just remove all options from this call, just leave expressions. So first we have some density plot on the color key. That means that red values are used more frequently than these yellow values. Yeah, so we have a lot of red cells in our heat map. But actually, people don't like this, and we want to remove it. So for that, we can use density information node. Put it here, rerun, and see no density information here. Now about these strange lines here, strange traces. What is that? At each column, we have some dashed line, which indicates that mean expression level. Here is it, just orange color. And if our value is lower than mean level, then solid line is drawn at left of this dashed line. And if it is yellow, it is drawn at the right. So I don't know why it should be used and why it is the default option in heatmap2 function. So every time you want to draw heat map, first of all, you put these two options here just to prevent traces and density info. And then, okay, and then our heat map is more clear now. So what we want then we see that our gene names are not fitting in our PDF. They are truncated here. So we can add some margins. For example, 12, 12. You can modify these values as you want. And here we see that now they are really fitted here. Okay, and then we see that row names, sample names are covering each other, and we want to reduce font size. For that, we have option CX row. So 0.5 is a percent related to the initial font scale. So when I type 0.5, it means please add font size 2 times less than initial one. So when we run it, we see that they are not overlapping here, and this is great. And the most challenging part is then to mark groups in this plot, because we know that H clustering, it's just hierarchical clustering here, it reordered our rows, and we see some groups here. For example, we see yellow there, red there, long red there, and we think that this reordering actually matches with our groups, our 4 clinical types, and we want to add some colors to indicate which group is where. For it, there's an option called row side colors, in which you need to pass an array of colors associated with each of the group names. So for that, we should prepare this array first. So we have an array called groups. Let us print it and see what it is. Yeah, here's group. Group is just an array. Top line is a header with group names, and we want to convert them into the colors. For that, we initialize an empty array of row colors, iterate through groups, and just some ifs. If group is luminal, then color is cyan, normal like orange, and so on. And after that, we append this color to the row colors array just by calling C. Do you know what C means in R? C is just for creating an arrays. So we just concatenate to arrays by this line. And then we can pass this option to the heat map and see the thing that which is not possible to do in Excel. You see that this is a luminal group, and I don't remember group names and their colors, but
okay, but
this
that actually is the point. So Yes.
Yeah, and one more thing there, that remember we set linkage type to ward dot. Let us see now. Yeah, let me run this. We see that there are some kind of not perfect reordering. You see that this group is splitted by orange group, and there are two luminal types. So ward.d2 is just another modification of the algorithm, which affects to the way how distances between clusters are calculated. And if we append this long line here, not here, it will use this linkage type for dendrograms, and here you see better clustering. And here we see, for example, an outlier. Here is it. And it's actually luminal, but it's more similar to basal.